So our next speaker today is Megan Price, who is Executive Director of the Human Rights Data Analysis Group. So over to you.
Thanks. Well, good morning. I'm very excited to be here. I'm very excited to mostly have my voice back today. And as Emily mentioned, my name is Megan Price, and I am the Executive Director of the Human Rights Data Analysis Group, or HRDAG. And we are a team of scientists who work essentially as statisticians for human rights. We partner with other human rights advocacy organizations to identify questions that can be answered or arguments that can be strengthened through quantitative analysis. And through that work, we've learned to think very hard about what's included and, just as important, what's not included in the data we rely on for those analyses. And specifically, we worry a lot about the impact that untold stories are having on the substantive conclusions we're trying to draw from our analyses. And so it's through that lens that I think about machine learning models, or if you prefer, predictive algorithms, or I suppose if I have to, artificial intelligence. But I'm today going to call them machine learning models, or just models. Because those models also rely on data as inputs. And that data is inevitably incomplete and imperfect. And so we need to worry about what impact is that having on the predictions that ultimately come out of those models and the decisions and the actions we might be taking based on those predictions. And so this morning, I'm going to give you very briefly two examples, and I'm going to argue one ultimately harms human rights and one ultimately has the potential to help. And so I'll start with work conducted by my colleagues Christian Lum and William Isaac. And what you're looking at on the left is an estimate of drug use in the city of Oakland. And as you can see, drug use happens kind of everywhere based on a national survey. And on the right is information observed and recorded by the Oakland police about drug crimes. And this is data that was collected and organized by OpenOakland.org. And as you can see on the right, the observed and recorded data about drug crimes are in very specific neighborhoods and locations and are a very small subset of the overall drug use that we think is likely happening in Oakland. And yet, it's this small subset on the right that is typically the input to a predictive policing model. And what Christian and William are able to show very rigorously is that the result of that is that the impact of those predictive policing models that inform police forces and the strategies that they use in allocating their resources disproportionately affect historically over-policed populations. Now, there's been a lot of discussion about whether predictive policing algorithms specifically, or more generally algorithms being used within the US criminal justice system, are fair. And it turns out that fair is actually kind of hard, not hard to define, but there are multiple different ways to define it, both in words and in math. And which definition you use determines the kind of test that you're going to use to evaluate these algorithms. That's way more than I have time to cover this morning, but I wanted to point you to these two excellent resources that really dig into and describe in great detail the complexities of evaluating whether or not an algorithm is fair. I want to move now to my second example. This is work done by my colleague Patrick Ball and partners in Mexico, Data Civica, and the Human Rights Program at Universidad Iberoamericana. And what they've done is they've built a machine learning model to predict the location of hidden graves in Mexico. Now, these are graves that are discovered from time to time across the country, and our partners used newspaper clippings to identify counties where these graves had already been discovered. And then they also used their contextual knowledge to identify counties where they're fairly certain these graves probably don't exist. Now, that's very tricky because the absence of evidence is not evidence of absence. But based on their contextual knowledge, they're fairly sure. So we have this subset of counties that have been labeled as containing a grave and not containing a grave. And then we built a machine learning model to predict for the unlabeled counties the probability that they probably also contain one of these hidden or clandestine graves. And when we showed the results of this model to our partners, this is the highest probability counties, they weren't really surprised. They said, of course, this is where the violence is occurring in Mexico. And so what was interesting in this project was not that the model necessarily had something new to tell us. It was that it offered a new advocacy tool to the groups that are representing the families of the victims so that they could petition the state and say, look, it's not just us calling for these investigations. There's science and there's technology backing us up. And so we're just in the early stages of seeing how they can use this as an advocacy tool. But the point that I want to make this morning is that both of these examples use very similar modeling technology, and they both rely on incomplete and imperfect data. And yet, I would argue that in the case of predicting missing graves in Mexico, we have the potential to do good. And when this model fails to identify a certain kind of grave, what we have done is we have missed an opportunity to do good. Whereas with predictive policing algorithms, what we're doing at best is replicating the bias that's already present in our policing system. And at worst, depending upon how they're being used, we're exacerbating and enhancing that bias, and we're hiding it behind an algorithm that seems objective. And I just want to close by saying that this is nothing new. In 1897, criminologists were saying that police data is so partial and so selective that we can't use it to draw conclusions about patterns of crime. Also in the early 1900s, most of the statistical profession was arguing over how to sample data and how to draw conclusions about samples of data. But they reached consensus. And they have ideas now about what to do with missing data and how to adjust for bias. Now, they were worried about inference, which is slightly different from prediction. But the lessons still apply. And so I want to use this week's theme of drawing power from proximity, and I want to call for all of us to do more interdisciplinary work. It's not possible for us to know about all the different work that's being done in different fields. So let's draw our colleagues closer. Let's talk about our problems, and let's listen in case their fields have some insight to offer to the things we're struggling with. Thank you very much.
Thank you so much for that, Megan. We have a lot to talk about. So I actually want to pick up on, it's sort of related to the question that the woman over here asked of Ramesh, which is to get quite practical. So you've given a great example of a dangerous case in terms of predictive policing, but also a positive use case in terms of the example you gave from Mexico. And so, what I'm really interested in is understanding what an ethics of algorithm development could actually look like. And, perhaps you could provide a small set of core principles as we all go forth and find ways to be working together and better collaborating. What is that kind of core set of principles that we could be using?
Yeah, absolutely. So I'm going to cheat a little bit, and instead of offering a core set of principles, I'm going to point to the other folks who are working on this, because the good news is that a lot of people are asking that question now. And everything from data science classes at universities are now incorporating issues of ethics, to organizations like the Fairness, Accountability, and Transparency in Machine Learning and in other fields now are putting forth really deep thinking about ethics. In the US, DJ Patel is struggling with this, and AI Now is putting out a lot of AI impact papers, really thinking through all of these issues. So the one thing that I want to say, though, and just to be absolutely clear, I'm definitely pro-ethics, and I think it's good that we're thinking about these things. But
I'm glad we got that out of the
way. But in keeping with the theme of this session, I think it's also important to think about some potential unintended consequences. And I think about this from the perspective of at universities' institutional review boards, which I also think are in general a good idea, but often get used to stifle research. And in particular, the thing that I worry about is that researchers at universities have to fulfill institutional review board responsibilities, but researchers at other institutions sometimes do not. It depends on sort of where that research is being conducted. So if we think about, if we create something like an IRB for algorithms, well, is Facebook going to be beholden to that? Is the local police force going to be? So I want us to think really big about how are we not only going to develop a set of guidelines and a set of ethics, but how are we actually going to apply that evenly to all of the different areas that are going to be using this technology.
Great. Well, that is a lot of food for thought. So with that, let's open it up to the audience for a question. I don't know who raised first. I think she did. Mary in the white shirt. Sorry. Thanks. We'll talk after.
It's okay, I'm around.
Are you sure? Okay. Thanks for that. My name is Noura. I work with the MasterCard Foundation. And we're interested in the kinds of algorithms that essentially decide on access with regards to, be it financial services or potentially the hiring decisions, et cetera. So I'm curious if, I'm curious whether you actually got your hands on the police algorithm that you studied and how that went, how they gave access to, or whether it was already open. And B, if you're doing any work or you know of any work on the types of algorithms on financial inclusion and also hiring, firing, et cetera, because there's a lot of bias in that as well, right?
Yeah, that's a great question. Thank you. So the specific policing algorithm that we used was Predpol. They did not grant us access to it, but they are the only, that I'm aware of, they are the only group that is published in a peer-reviewed journal about their work. And so there was enough information in that journal for Christiane and William to back calculate what the algorithm was. So they sorted it out that way. As far as your other question, not yet. So far, we've only looked at policing and criminal justice more broadly. But wow, those financial decisions and hiring and firing are fascinating and need to be dug into.
Agreed. So thank you so much, Megan,
thank you.
for your talk.